So here's our situation. We're going to write the net ionic equations for a reaction between each of the following things here. So we start off here with MgCl2 plus Na3PO4. So for this particular reaction, I'm going to, for right now, add a plus sign right here. And so let's just write out our general, overall, normal chemical reaction here. We'd recognize that this is a double displacement reaction. So what's going to happen is we're going to have magnesium as the first cation here is going to go with phosphate. PO4 right here to balance this out. Magnesium, if we recall, has a +2 oxidation state. Phosphate is going to be -3. If you don't remember it, you can look it up on our chemical nomenclature sheets here. And so to make this work, so magnesium is +2, phosphate's -3. And so to get this to work, this is going to have to be Mg3, open parentheses, PO4 2. To get that to work out. And then to finish this out here, we're going to say the sodium ion is going to go with the chlorine ion, the chloride ion out here. Now chlorine, if we recall, is got an oxidation state of -1, definitely not -1, otherwise it would be an anion. Sodium is +1, and so these two already balance out for NaCl. Then we do have to balance the equation, and so right now we have 1 magnesium on the left, 3 on the right, so we're going to put a 3 out front here. That gives us 6 chlorines, and so we're going to put a 6 out here. That gives us 6 sodiums, so we have to put a 2 out in front of this one. That gives us 2 phosphates, and we have 2 phosphates over here. So this would be our regular way we write out and balance this equation. Now, what we want to do next is we want to look at what is the net ionic equation for this reaction. And so to do that, we have to say, well, which one of these are going to be soluble in water, and therefore we're going to break up into ions and which aren't. Now, just taking a look at this, we can identify that all of these substances should be ionic right off the bat. So we don't know if they're soluble or not, but we do know they should be ionic because of the fact that magnesium and chlorine, their electronegativities are sufficiently different that they would be ionic here. Sodium phosphate, since it involves phosphate, a polyatomic ion, it's going to be ionic here. And sodium chloride, the other one at the very end here, is going to be ionic because of the fact that sodium and chlorine have a big enough difference in electronegativity. So we do know it's ionic here for each of these substances here, but we don't know if any of them are going to be insoluble or not and will precipitate out of the reaction. So let's take a look. MgCl2. So if we go way on back, we look at this. So MgCl2 is chloride. So it tells us that chlorides are typically soluble unless it's got silver, and that's it, right, for chloride. So that means this is going to be soluble. And so we would be able to write this out, going all the way back to where we were before here. And so if we're writing this guy out here, we would say that we've got magnesium, and so it's going to be +2. So you do +2 up here, 2+. And it is going to be dissolved in water, so we'll say an AQ. See if I can fit this all in here. And then plus, our next ion is going to be the chlorine. And so for the chlorine right here is that we'd say that's going to be Cl- right here, also still an aqueous solution. So we're going to dissolve that here to show that it's an aqueous solution. Next we're going to look up here is to write the total ionic equation, Na3PO4. So that's sodium phosphate. Once again, looking all the way back, is that phosphates, does that show up here? Phosphates is right here. It tells us that phosphates are insoluble, but it does depend on is the cation an alkali metal or ammonium. And sodium is an alkali metal, so it is going to be soluble. And so we know that also is going to be soluble here. And so then we would write out for this Na, and then that'll be plus because it's a cation, it's +1 is its oxidation number as an ion here. And then we have the phosphate. So the phosphate's -3, so we'll do plus PO4 and then -3 here. And that's also an aqueous solution. And we will see if we can fit all this on here. So then do our little arrow right over here. And so on the other side, we say Mg3PO4, magnesium phosphate. So looking back at our rules here, phosphates, it said, are insoluble unless it has alkali metal or ammonium. Well, magnesium is an alkaline earth metal, not an alkali metal. So this is insoluble because phosphates are insoluble unless they're one of those two. So then we write this out in our total ionic equation. Then we actually are going to have to write out this whole Mg3, open parentheses, PO4. We don't write it out in ions. We're going to instead say it's going to be a solid because of the fact it's insoluble here. Then we're going to keep going. And so on the next part here, we have to look at NaCl. And so sodium chloride. Well, right off the bat, we should know that sodium is an alkali metal. Alkali metal compounds, alkali metal salts, always soluble. And so this is definitely going to be something that we're going to need to write out in terms of our ions here. So Na plus in aqueous solution, and then plus chloride, Cl minus in aqueous solution, to show that's how it works here. All right, now we do still have to balance this. The balancing should be pretty similar to what it was at the top, though, because we look at this, we say, all right, we have one magnesium over here on the left side, which is the top on this, right? And then we have 3 magnesiums down here, so we'll put a 3 in front of this guy right here. Let's look at next the chlorine, so the chloride ion, 1 chloride ion, 1 chloride ion here. That seems to work so far. Sodium ions, 1 sodium ion, 1 sodium ion. That seems to work so far. Phosphate, we have 1 phosphate ion right here, and we have 2 phosphate ions right here. So we're going to have to put a 2 right up there. But here's the thing. I want you to notice that phosphate ion, even though it's loose right now, originally came from being right up here. And so in order to make this right, to balance out here, we've also got to have 2 of these sodiums, or actually not 2 of them. We've got to have 3 sodiums for every 2 phosphates, or 3 sodiums for every 1 phosphate. So that means we have to have 6 sodiums in here. And so this actually gives you a little bit of hint about how you want to do this. It's usually easier to go ahead and write off the regular equation and balance it first. And then once you've done that, use those numbers to balance out your total ionic equation rather than try to do it sort of like we're doing right here. I'm sort of doing this the wrong way to show you why you wouldn't want to do it. So continuing on this, what we do is then we'd say, all right, hey, now we have 6 NAs, so we're going to put a 6 down here. And then the last one is the chlorine ions. And the chlorine ions, well, because of the fact we had 3 magnesiums up here, and there are 2 chlorines for every 1 magnesium, means we have to have 6 right up here. But I want you to watch what this would look like if we just use the original one. We would just say, oh, I got 3 magnesiums, put a 3 right up there. I've got 3 times 2 is 6 chlorine, so I put a 6 right there. And then for the next one, that we would say that you have 6 sodiums, so we put 6 sodiums out here, 2 phosphates with the 2 phosphates here, and do the same thing that's on the left side. Sometimes also the way this is done is that, I'm going to sketch this out as well, because you'll see this sometimes also. Instead of writing this out where you do it like we did right there, sometimes what you'll do is you'll see brackets be put around ions that are sort of separate here. And then the 3 goes in front of the bracket to show that this is sort of the ratio here. The only thing you have to do if you're doing that is you got to put the 2 in front of the chlorine right here to indicate the right ratio. And so it is possible to do it that way. So if you do, that's how you have to do it. I'm not going to really have a preference. Either way you can do it here. So it sort of depends on the format that you need. So if you're doing it that way, then for this one we have 2 of these NaPO4s right out like that. See if I can erase this without messing everything up. So plus, and then we say there's going to be 2 right there. And then we have to put a 3 in front of that Na inside the bracket. And then we have to put, it should be it on that one, since we don't need the 2 in front of the phosphate right there. Excuse me. And then we can do the same thing at the end whenever we get to our NaCl, because we actually forgot to put the 6 out on the end of this one. So we really need to have that bracket out there, otherwise that wouldn't be right. And then we can, once we get done, we can cross-check to make sure we have the same number on both sides, which in this case we should. We got 3 magnesiums, we have 3 magnesiums, we have 3 times 2 is 6 chlorines, we have 6 times 1 is 6 chlorines. For sodiums, we have 2 times 3 is 6 sodiums, 2 times 3 is 6 sodiums right here. And then for our last one, I think is phosphates, we have 2 times 1 is 2 phosphates, and sure enough, we have 2 phosphates down here. So this would be our balanced total ionic equation. So it gets a little harder here. But let's look for our spectator ions. So spectator ions are the ones that do not change. They are not changed by the reaction. They're not involved. Magnesium gets turned from an ion into being part of a compound. So it is not a spectator ion. Chlorine starts off as Cl minus, ends up as Cl minus. That's a spectator ion. So cross it out. We do not want that involved for our net ionic equation. Then for our next one is going to be The sodium, the Na+, we have sodium ion first. We end up with a sodium ion, so we're going to cross that out. And so that is going to be gone now. And so then we get to our last one right here, which is the phosphate. We have a phosphate right here. We have a phosphate. The phosphate is involved in the precipitate right here, the precipitate. And so therefore it is going to be involved here. So we just want to get rid of our spectator ions, which are going to be the chloride and the sodium. And so if we were writing this out, I'm going to do it up top because I've run out of space here, you would say this is going to be Mg plus 2, and then plus, what's the next one that's not a spectator? PO4 minus 3. And it's going to yield what our precipitate is here, which is Mg3PO42. So I'll write it down here, Mg3PO42. In this case, we can just balance this. And so for this one to balance it out, we'd say that we've got the Mg3. So we put a, oops, that was not the one I wanted. Let's try that again. So Mg, put a 3 out there to make that work. 3, so I have the right color here. And then we have 3 Mgs, we have 2 PO4s, so we put a 2 out in front of this, and that should make this balance out. And so that one up top is going to be our net ionic equation for this particular reaction. So let's take a look at our next one. So Al2SO4 and BaCl2, going to be another one of our double displacement reactions. So we have aluminum sulfate, barium chloride, should produce aluminum chloride and barium sulfate. So normally if we're just sort of writing these out, then just figuring out what we have here. So we have AlCl, which is going to be AlCl3 to balance the valences. Aluminum is plus 3, chlorine is minus 1. And then we'd have barium sulfate, BaSO4. Barium is plus 2, sulfate's minus 2, so that works out nicely. So balancing this out, in our traditional equation, our traditional one here, we say 2 aluminums and 1 aluminum, so we put a 2 out front, 3 sulfates and 1 sulfate, so we put a 3 right there, 3 bariums, 1 barium, so we put a 3, there's a 3 right there, gives us 6 chlorines, and 2 times 3 is 6, so that works out pretty well for that one. But let's look at each of these and see how many of these are going to be soluble and how many aren't. So we have aluminum sulfate, barium chloride. So let's take back a look here. So aluminum sulfate and barium chloride. Aluminum sulfate, we look over here, we see that's a sulfate, and so that is soluble unless aluminum is one of these, and aluminum is not one of those. So therefore aluminum sulfate is going to be soluble. The other one is barium chloride. Well, chlorides are right here. And so is barium, so that's going to be soluble unless it's one of the exceptions. Is barium one of the exceptions? It is not. So both of these are going to be soluble. So we know, just to start off with on here, that our 2 of these guys are both going to be soluble. So that means we can go ahead and write them out in terms of their ions. I'm going to leave off the phase notation for right now, at least on the ions, just to save space. So we'll have Al, and so that's going to be 3 plus, or plus 3 right here, plus sulfate, which is going to be SO4, 2 minus, or minus 2. So we have those 2, we're going to break up here, and then our barium chloride, which is also, those are both ionic substances. In fact, all of these are ionic substances. If we check, and so barium chloride right here is going to break into ions as well because it is soluble and ionic, so it's going to be Ba plus 2 plus Cl minus right here. Let's not worry about balancing for right now. We're just going to set it up to start with, and then after that, we're going to look at our next ones here. So we have aluminum chloride and barium sulfate. So aluminum chloride, looking back at the rules, chlorides, we said right here, are soluble unless it's, so is aluminum one of the exceptions? It is not, so that means that this is going to be soluble. Aluminum chloride should be a soluble substance here. So aluminum chloride would be soluble, and so we can go ahead and write out the Al, let's see, what is that, plus 3? And then plus the chlorides, which are going to be Cl minus right there. And then the last one will be that barium sulfate. So we look back and look at barium sulfate. And we see sulfates here. Sulfates, it says, are soluble. Is barium one of the exceptions? Oh, barium is one of the exceptions. So that's insoluble. And so because it's insoluble, that's going to be the precipitate here. So this is a precipitation reaction. And so this one, we write out our last bit here, is just going to be plus, we write out the compound. BaSO4. You don't write out the ions because it doesn't break up into ions. All right, so this right here is going to be our total ionic equation, not balanced right now, because really, since we're just looking for the total the net ionic equation, we don't have to balance it yet. So let's just knock out the things we need to knock out. And so what are our spectator ions? Is aluminum a spectator ion? Yes, it shows up on both sides without being involved in the compound. We're going to knock that one out right there. So that one is gone. What about the sulfate, SO4? Is that starts off as a sulfate ion, but it ends up as part of the precipitate. It ends up part of a compound that is not a spectator ion. The barium, Ba2+, starts off as an ion, but ends up part of a compound. It's not a spectator ion. The chloride right here starts off as a chloride ion, ends up as a chloride ion. That one does not change throughout the reaction. That is a spectator ion. And so if we're writing out our net ionic equation, it would simply be this. It would be, I'm going to rearrange it a little bit just for purposes here. So Ba+2 plus SO4 minus 2 yields BaSO4. And then we're going to go ahead and put the phase notation on that to indicate what we have here. And then to balance this out, well, it's already balanced, so that's okay for writing out our net ionic equation. And so that's how you do that one. So let's take a look at our last one. So we have BaNO3 plus MgCl2, so barium nitrate and magnesium chloride. And so taking a look at these, let's just figure out what are going to be our products out of this. We'll use our standard one before. So this is another double displacement reaction. So we should have barium chloride, BaCl2 is what that should be, plus MgCl, so plus then it would be magnesium and nitrate together. So that would be magnesium nitrate. So MgNO3, balancing the valences, nitrate is -1, magnesium is +2, so we'd have to have 2 nitrates out here. So that's going to be our 2 products here. Question is, are they all insoluble, or which ones are insoluble, which ones are soluble? So we have barium nitrate, magnesium chloride. So taking a look back a little earlier here, so barium nitrates. So let's see if we see any nitrates here. No nitrates there. Any nitrates here? Oh, here's nitrates. So nitrates are soluble, no exceptions. So that means it's definitely going to be soluble. And our next one we said was, which one? Was magnesium chloride. So we look back on here. Do we see any chlorides? So there's chlorides right here. They are soluble. Is magnesium one of the exceptions? It is not. So this is soluble as well. So we have 2 soluble compounds to start this off. Then the ones afterwards are BaCl2, so barium chloride and magnesium nitrate. So barium chloride, look at that first. Chlorides, we said, are soluble. Is barium an exception? It is not. So barium chloride is soluble. The last one is magnesium nitrate. So nitrates are no exceptions, also soluble, which means all of them are soluble here. So in this case, every single one of these are soluble, which means that the overall total ionic equation is the same so it means that all of these don't change. We start off with a mixture of barium ions and nitrate ions and magnesium ions and chloride ions, and we end up with exactly the same thing, a mixture of barium ions and nitrate ions and magnesium ions and chloride ions, and so there are no precipitates here. This is not a precipitation reaction, and so there is no net ionic equation because all the ions here are spectator ions, because in reality, as long as, since these are all going to stay in solution, we start off with barium nitrates, nothing more than a mixture of barium ions and nitrate ions, and magnesium chlorides, nothing more than a mixture of magnesium ions and chloride ions, because of the fact they're ionic and they're both soluble. And the same thing is true for these guys here. This is not a real reaction. We would just put these in here, they dissolve into these 2 guys, into these ions here, to barium plus nitrate plus magnesium plus chloride, and they stay that way. This is something that looks like it's a reaction, but in reality really isn't a real reaction in a real sense, because all of these stay dissolved. And so there is no net ionic equation for this, because technically all the ions are spectator ions. It's really a no reaction at all here. And so if you never have a precipitate, if you have one where they're all starting off, they all start off dissolved, they're all soluble and ionic, and they end up as soluble and ionic, and there's no precipitate here, then there is no net ionic equation that you end up with.